Okay. So once again, good afternoon to all of you. I hope that my voice is audible. And thanks to all of you for showing interest to join in this FDP program on artificial neural networks. So before starting this FDP, so what are the workshops or FDP programs we conducted earlier in this academic year? I'm trying to discuss from that point of. So actually, we started. Actually, we started one workshop on first workshop we conducted that is called machine learning optimization. So machine learning optimization, that is the first workshop we started in this academic year. So in this machine learning optimization, we discuss about what mean by the optimization, how this optimization techniques will be useful in the machine learning training process, and what are the different types of variants of gradient descent optimization algorithms that also we discussed in this FDP, that is called stochastic gradient optimization method, batch gradient descent optimization method, and mini batch gradient descent optimization method. And also we discuss about the ADA grad, and we discuss about the ADA delta, and we discuss about the RMS prop, and we also discuss about the ADAM optimizer in that FDP in the workshop. So in the first workshop, we mainly concentrated on various types of optimization techniques that are used in machine learning to train any machine learning or deep learning model, or how these optimization techniques are useful to update the model parameters of any machine learning model that we discussed in that workshop. We covered all. That means we mainly focusing on the optimization only at that time. So for that point of view, we considered only a simple linear regression model, a machine learning model we considered to explain all these optimization methods. To explain all these optimization methods, we considered this part, simple linear regression model. And later, second workshop we started in October, I think October and September, that is called machine learning models and applications, machine learning models and applications, that also we started. So in this workshop also, again, we included one day, we use one day, complete one day, that is the 2 sessions on again machine learning optimization, because so the participants who registered for this workshop, few participants are new. They don't know about the concepts what we discussed in the earlier workshop. That's why we incorporated this topic as a first day content, because the optimization is required to understand the how model parameters will be updated in a machine learning model during the training process. That's why, so we again on day 1, we included the machine learning optimization, but we not discussed all the variants of the optimization algorithms, but only we discussed the SGD in the day 1 of this second workshop, because that is essential. Understanding the optimization method is essential to understand the machine learning model training process. And this is the third workshop, third FDP we started, that is called as the ANN, that is the artificial neural networks. In this artificial neural network also, day 1, we are trying to dedicate complete day 1 for the machine learning optimization again, because whether it is a simple machine learning models or it is the deep learning models, optimization, understanding of the optimization is required. So that's why on every FDP or workshop related to the machine learning or deep learning, we are trying to dedicate one session on the optimization. So that's why today I'm trying to concentrate much on the machine learning optimization or the deep learning optimization. That is the day 1. Whereas on day 2, I'm trying to discuss about the ANN architectures and different types of learning rules and its implementation using either Python or MATLAB. Either Python or MATLAB. Okay, that is the day 2. And on day 3, so we discuss about the how ANN will be useful for the regression problem. And on day 4, we are trying to concentrate. Day 4, we are trying to concentrate on how ANN will be useful for the classification problems. And on day 5, we are trying to focus on how ANN will be useful for the clustering problems and also computer vision problems. So this is the actual flow for this FDP, 5 days FDP. So first day 1, we are mainly focusing on the basic requirement, that's the machine learning optimization. On day 2, we are trying to discuss about the ANN architecture discussion and what are the different learning rules are available. On day 3, we are trying to focus on the ANN for the regression problem and how ANN for the classification problem, how ANN can be used for the computer vision and clustering problems. And we are trying to implement everything using the Python or either the MATLAB. So actually, I'm happy with the 22 participants, but the number of members joined in this program as of now, it's only 8. It's slightly disappointing. But okay, many people have many works, but thing is, so everyone will get the participation certificate. But every day, at end of the every day, there will be 2 assignments will be posted in the canvas. And you have to submit the solution for those assignments before the closing of this FDP. So based on the responses given to the assignments in the canvas, you will get the course completion certificate. So the course completion certificate is completely depending upon the how you submitted the assignments in the canvas for every assignment, how you're submitting the solutions for the assignments given in the canvas. So meanwhile, if you have any questions, can please ask. Actually, if it is a more active, that will be more interesting for the resource persons. So now first we will discuss about the machine learning optimization. So we are going to discuss about we are trying to discuss about the deep learning optimization. We are going to discuss about the deep learning optimization. Deep learning optimization. Okay. So what mean by the optimization? So optimization is nothing but the either maximization or minimization of a particular objective or objective function. So that is called as the optimization. So optimization is called as the either maximization or minimization of a particular objective or a particular objective function is called as the optimization. In real life also, we will see many type of optimization things. For example, if we go to any DMart or any other supermarkets for the monthly grocery purchases. So what is our objective as a customer? What is our objective? Our objective is we are trying to purchase all the requirements at the minimum cost. At a minimum cost, I want to purchase all the required grocery for the month. So this is also one of the optimization problem because I am trying to minimize an object function that is called as the cost. So that is the optimization problem. Similarly, what is the goal of any owner of a DMart or Reliance Mart, whatever it may be, what is his goal? He is trying to maximize his profit. So his goal is he is trying to maximize his profit. So his objective is he is trying to maximize his profit. So this is also an optimization problem. So there are many optimization problems are like this. That means either minimization of a particular objective function or maximization of the particular objective function is called as the optimization technique or optimization problem. Okay. So actually, If we work for any client, he will give his requirement. That's it. He will tell his requirement. Maybe he will give his requirement orally, or maybe he will give his requirement in the form of the text document. So this is what I want, like that he will give some text document. But as an engineer, as a machine learning engineer or as a data scientist, if you want to work on that problem, on that requirement, you need to convert his requirement into the mathematical modeling. The client will give the optimization problem. Orally, or maybe in the form of the text format. But if you want to solve this optimization problem, it's not possible. You have to convert his requirements into a mathematical. That's called the mathematical modeling. So whatever the optimization problem we are receiving from the client, first we are convert that optimization problem into the mathematics. In the mathematical modeling we have to develop. Hope you understand what I want to say. So one minute, off minute, please. Right. So hope you understand what I mean to say. Okay. So whenever we receive any problem or any optimization problem from whom? From the client. Then that will be like a oral information. That problem may be oral, he will dictate, or sometimes he will give it in the form of the text format. But if you want to solve that problem, so you have to convert that optimization problem into the mathematical modeling. You have to build the mathematical modeling for that. For that optimization problem, we have to convert into the mathematical modeling. So in a mathematical modeling of any optimization problem, what are the main parts? So in mathematical modeling of any optimization problem, so we have few things. One is called as the objective function, and you have the decision variables. And you have the constraints. And also you have the boundaries. So these are the major parts in mathematical modeling of any optimization problem. So your optimization problem, when you are converting your optimization problem, when you are developing a mathematical modeling for your optimization problem, then that mathematical modeling will consists of objective function, decision variables, constraints, and also boundaries. Okay. Now, so what is the objective function? All the things we will discuss one by one. But I want to explain this information with a small case study. I want to explain all the things with a small case study. So the case study information is already posted in the Canvas. So already that I posted in the Canvas. I'm trying to explain that optimization problem, mathematical modeling with a small case study. I want to explain. So FDP, yeah, this one. Yesterday I created a Canvas course and I asked you all to join in this Canvas course. Right. So this is the small case study I am trying to explain for the development of the mathematical modeling. Let's consider this case study, this problem statement. Consider a chocolate manufacturing company. That means you are a data scientist or a machine learning engineer or deep learning engineer, and your client is a chocolate manufacturing company that produces two types of chocolates. One is called as the A-type chocolate, another is called as the B-type chocolate. Both the chocolates requires milk and chocolate. Okay, so you have a client. That client manufactures the various types of the chocolates. Types of the chocolates are A and B. Like maybe you can take it as a Snicker chocolates or whatever different types of chocolates, dairy milk sticker, like the 2 types of chocolates they will manufacture. To manufacture the both chocolates require the milk and chocolate. Okay. Now, to manufacture each unit of A, that means 1 unit of A type chocolate and 1 unit of B type chocolate, following quantities are required. What are the quantities? To manufacture 1 unit of A requires 1 unit of milk and 3 units of chocolate. If you want to manufacture one A type chocolate, it required 1 unit of milk and 3 units of chocolate. Similarly, to manufacture 1 unit of B type chocolate, you require the 1 unit of milk and 2 units of chocolate. Hope you understand. Okay. Now, the company kitchen has total 5 units of milk. The company has total 5 units of milk and 12 units of chocolate. So on each sale of the company makes a profit of 6 rupee per unit A. And for a unit B, if he sold 1 unit of B, he will get the 5 rupee profit. Now the company wishes to maximize the profit. How many units of A and B should be produced respectively? So the client is asking you how many units of A type chocolates, how many units of B type chocolates that company need to manufacture so that he will get the maximum profit. So this is the optimization problem. I think everyone will agree, because I am trying to maximize its profit. I am trying to, this is the information I have. So the client will give the requirement in the text format. But if I want to solve this one, I have to convert into a mathematical modeling. So how we convert into mathematical modeling, we will discuss. So hope you understand that problem. So he's trying to maximize the profit, right? So I'm trying to maximize profit. So how we can develop the mathematical modeling for this profit? How we can develop the mathematical modeling for this profit? So that's equal to, you can see here, 6 rupee profit for 1 unit of A, 5 rupee profit for 1 unit of B. Now the client is asking how many units of A and B how many units of A and B he should produce so that he get the maximum profit. Okay. Let's assume X number of A type chocolates and Y number of B type chocolates. If the company produce, he will get the maximum profit. Let's assume. That means we need to calculate the what is the value of X and what is the value of Y. Okay. So X number of A type chocolates and Y number of B type chocolates. X number of A type chocolate and Y number of B type chocolate. Hope you understand, right? Fine. Now you can see for 1 unit of A type chocolate, we got the 6 rupee profit. If it is the X number of A type chocolate, how much profit he will get? 6 into X. Similarly, for 1 unit of B type chocolate, he will get the 5 rupee profit. If for a unit of, but Y units of B type chocolates, how much profit he will get? 5 rupees profit for 1 unit of B. Number of units of B equal to Y. So total profit will be 5 into Y. So what is the total profit? 6x profit on the A type chocolate plus 5y profit on the B type chocolate. Now I am trying to maximize this profit by calculating the X and Y values. Right? Hope you understand. Next, please listen carefully here. Next, now see this part again. For each unit of A, that means for 1 unit of A requires how many units of milk? 1 unit of milk. For 1 unit of B, how many units of milk is required? 1 unit of milk. Agree for these two statements. Now come to here. For 1 unit of A requires 1 unit milk. For X units of A, how many units of X milk is required? For 1 unit of A requires 1 unit of milk. For X units of A, how many units of milk is required? I think that's right. So 1 unit of A, 1 milk. If it is X units, 1 into X. 1 into X. Milk units are required. Similarly, for 1 unit of B, 1 unit of milk is required. If it's the Y units of B, how many units of milk is required? 1 into Y. So that means this can be written as X plus Y. It is the total number of milk units are required. Total number of milk units are required. But you can see the constraint here. Total number of milk units are 5 only. You can see here. Total number of total units of milk are 5 units only. So this should be less than or equal to 5. Similarly, if you go to Choco, for 1 unit of A required 3 units of Choco. If the X units of A, how many units of Choco required? 3 into X. Similarly, for 1 unit of B required 2 units of Choco. If it's a Y units of B, how many units of Choco required? 2 into Y. So total Choco required is 3X plus 2Y, right? Now, how many units of Choco units are available in the company kitchen? How many units of Choco are required in the company kitchen? 12 units, right? So that's why that should be less than or equal to 12, right? Hope you understand as of now. So this is how we are going to develop the mathematical modeling. How we are going to develop the mathematical modeling for the problem given by your client, right? So this is a complete optimization problem because he is trying to maximize his profit. That's why it's called as a optimization problem. So it's called as a optimization problem. It's called as a optimization problem. Hope you understand, right? Now, finally, what we are going to tell? What we are going to tell to our customer or to our client? We have to give the information to our client that these number of A-type chocolates, these number of B-type chocolates, you should produce so that you will get the maximum profit. So these number of A-type chocolates, these number of B-type chocolates never be a negative value, right? Never be a negative value. No one will tell -2 units of milk, Snicker you have to produce. What is the -2? It should be 0. That means don't produce, or it should be some positive value. It should be positive value. So your X and Y, that is called as the number of A-type chocolates, number of B-type chocolates, never be a negative value. It will be 0. That means you are suggesting that don't produce the A-type chocolate or don't produce B-type chocolate. That's a 0. That means otherwise it is positive, maybe 2, 3, 10, 100, whatever it may be. That means your X and Y value should be real positive numbers. So that's why X should be greater than or equal to 0 and Y should be greater than or equal to 0. This is how we can build the mathematical modeling for a optimization problem as per your client requirement. As per your client requirement. Okay. Now, my intention here to explain all the things is what are the different components that exist in an optimization problem mathematical modeling. That first part is called as the objective function. So this is called as objective function. So objective function means the function what we are going to either maximize or minimize. So that is called as the optimization problem. Objective function. So that's what I mentioned in the previous case. So main parts of my optimization problem mathematical modeling is objective function, decision variables, and the constraints and boundaries Okay. Now, so that's why this part is called an objective function because we are trying to maximize that objective. That's the profit. So that's called as an objective function. That is one of the key parameter in your optimization problem. After that, so what is this X and Y? X and Y are called as the number of A-type chocolates, number of B-type chocolates. So these X and Y values will decide your objective function. These X and Y values will decide your objective function, right? So these two values are called as, this X and Y are called as the decision variables. So this X and Y are called as the decision variables. X and Y are called as the decision variables. So object function is completed, decision variables are completed. Now coming to the constraints. So constraints means again, the constraints are the two types. One is called as the inequality constraint and another is called as the equality constraint. Inequality constraint and equality constraint. Okay. Now you can see this current mathematical modeling of current problem. So x plus y less than or equal to 5, 3x plus 2y less than or equal to 12. So these are called as the constraints. These are called as the constraints. Especially you can call it them as a inequality constraints. So these are called as a inequality constraints. Why these are called as inequality constraints? Because here we are using a parameter called less than or equal to. Here we are using a parameter called less than or equal to. Okay. So this is we are using that's called x less than or equal to. That's what it's called inequality constraint. Then you may ask, so what are the equality constraints? In place of the less than or equal to or greater than equal to, if you have only equality sign, then those constraints are called as the equality constraints. Those constraints are called as the equality constraints. So hope everyone is following. So these are called, so because here we have the less than equal to, or sometimes you may have the greater than equal to or greater than equal to. So such type of things, if you have those such type of constraints are called as the inequality constraints. But in place of less than or equal to, if you have only equality sign, then such type of constraints are called as the equality constraints. So in your mathematical modeling, you have an objective function, you have a destiny variables, you have the constraints also. And you have one more parameter that is called as the boundaries. So this is called as the boundaries. That means your destiny variable is lying in its region. Our destiny variables x and y are lying in which region, in which area, at what area it will be occupied. So that is called as the boundaries. What are the boundaries? What is the lower limit? What is the upper limit for your destiny variables? So that is called as the boundary conditions. Hope you understand. So this is the boundaries are the boundary conditions. So my boundary conditions are x less than or equal to 0 and y less than or equal to 0. So these are the main parts in your optimization, mathematical modeling of your optimization problem. Mathematical modeling of your optimization problem. Hope you understand, right? Done. So yeah, as of now, you have to understand this part, right? Now, next topic is, so now what we discussed, we discussed about the what mean by the optimization and how we develop a mathematical modeling for an optimization problem. And later we discuss about the what are the different components in a mathematical modeling of an optimization problem. Now later we will come back to this problem again. We are going to implement it in Python. We will come back to this point later. And next topic, we are going to discuss about the different types of the optimization problems. So types of optimization problems. So basically, these optimization problems are mainly classified into two categories. One is called as the linear optimization problem. Another is called as the non-linear optimization problem. We have the linear optimization problem and the non-linear optimization problem. So your optimization problem is classified into two categories. One is called as the linear optimization problem, another is called as the non-linear optimization problem. Okay. Now we will discuss what mean by the linear optimization problem and what mean by the non-linear optimization problem. So linear optimization problem means in the linear optimization problem, your objective function is linear function of the decision variables. Your objective function is linear function of your decision variables. So this example what we discuss now, that is the linear optimization problem, because my objective function profit is a linear function of my decision variables x and y. Is a linear function of my decision variables x and y. Agree, right? So that linear optimization can be written as maximize something profit equal to 6x plus 5y. So this is the example for the linear optimization problem, because my objective function is the linear function of my decision variables, that is called as the linear optimization problem. And nonlinear optimization problem means, so like your object function minimize some function f of x equal to x square plus 5. Because here my objective function f of x is not a linear function. It is not a linear function of my decision variable x. Or you can take it as x square plus y square plus y, 5, like this. So my objective function f of x comma y is not a linear function of x and y. It is a non-linear function of x and y because you have the square terms. It is the linear function of x and y. That's why this type of optimization problems are called as the non-linear optimization problem. Non-linear optimization problem. Hope you understand. So what is the basic difference between the linear optimization problem and the non-linear optimization problem? Okay. Now, Again, further, the linear optimization problems are further classified into two categories. One is called as the constrained linear optimization problem or unconstrained linear optimization problem. It will be classified as constrained linear optimization problem or unconstrained linear optimization problem. Okay. So you may have a question, what mean by the constraint, what mean by the unconstrained? Constraint optimization problem means in the constraint optimization problem, you have the either equality constraints or inequality constraints in your mathematical modeling of your optimization problem. You have equality or inequality constraints or both in your mathematical modeling of an optimization problem. Then it is called as the constraint optimization problem. Like for example, the case study what we discussed, maximize profit P equal to 6x plus 5y and x plus y should be less than or equal to something, I forget, maybe 5, and 3x plus 2y is less than or equal to 12. So we have the objective function and we have the constraints also. That's why it's called as a constrained optimization problem. Constrained linear optimization problem. This is called as the constrained linear optimization problem. Whereas in case of the unconstrained, you don't have any constraints. You don't have either equality constraint, you don't have any inequality constraint. Then it is called as the unconstrained optimization problem. That means you are trying to maximize P equal to 6x plus 5y. 6x plus 5y. There is no constraints. Then so this is an example for unconstrained linear optimization problem. Is the example for unconstrained linear optimization problem. Hope you understand. Similarly, nonlinear also same thing. So nonlinear optimization problems also further classified into two categories. One is called the constrained nonlinear optimization problem or unconstrained nonlinear optimization problem. You have both constrained and unconstrained nonlinear optimization problem. In case of the what is the constraint optimization? Same. What we discussed like in linear case here also same. In constraint optimization problem, you have the objective function like f of x comma y equal to x square plus y square plus 5. And also you have some inequality constraints or you have some equality constraints like this. Some equality constraints. So like this you have. So this is that means in your constrained nonlinear optimization problem, your objective function should be nonlinear function of your decision variables x and y, and also you must have some the equality or inequality constraints. That comes under the nonlinear optimization problem. Nonlinear optimization problem. And coming to the unconstrained, you have the only objective function. There is no constraints. There is no constraints. Then it is an example for the unconstrained nonlinear optimization problem. Then the example for the unconstrained nonlinear optimization problem. I hope you understand the difference between the linear optimization difference between the what mean by the optimization, what are the different parts in a mathematical modeling of the optimization problem, what mean by the linear optimization, what mean by the nonlinear optimization, what mean by the constrained optimization, what mean by the unconstrained optimization. You are able to understand, I hope. Okay. So this is the whole classification of the optimization problems. Okay. So first we will discuss about the implementation of the linear optimization problem, and you have an assignment also. You have an assignment also here. Okay, based on the linear optimization problem. So later we will discuss about the non-linear optimization problem. There is a one more assignment also based on the non-linear optimization problem using the, so that we will going to discuss in this in today's sessions. Okay. So hope you understand outment by the optimization, all the things. Now we are trying to discuss about the this case study. Yeah, you can see here. So consider the chocolate. This case study only I will explain once again. So this is the case study completely we discussed it, and its mathematical modeling also we discussed. 6x plus 5y, x plus y less than or equal to 5, 3x plus 2y less than or equal to 12, x and y should be greater than or equal to 0. Should be greater than or equal to 0. So this is the the problem statement given by my client, requirements of my client. Now I'm converting that requirements into the mathematical modeling. So once we convert this one into the mathematical modeling, we need to use any of the programming language. We can use any of the programming language to find the solution. Okay. So now, so how we solve this optimization problem? So actually in Python or in the MATLAB, what are the methods or what are the libraries are available to solve the linear optimization problem? To solve the linear optimization problem, they are dedicated for the minimization problem. They are dedicated for the minimization problem. So, but here we have the maximization problem, right? Where you have the maximization problem means. So now you have to convert this maximization problem into the minimization problem. So how we convert the maximization problem to the minimization problem? Simply keep the negative sign. Actually, our mathematical modeling for our problem is maximize 6x plus 5y and x plus y less than or equal to x plus y less than or equal to 5. Sorry, x plus y less than or equal to 5. And we have the 3x plus 2y less than or equal to 12. And x comma y is greater than or equal to 0. This is what mathematical modeling we developed. But in Python or MATLAB, it will not support for the maximizing a function. It will be used to solve for the minimization problems. Then how we convert this maximization problem to minimization problem? You can keep all the things as it is. Don't change anything. Constraints or boundaries, you no need to change. But what change you have to incorporate? Instead of maximization, you can convert into minimization simply by multiplying with the negative sign. So maximize 6x plus 5y is nothing but the minimize minus 6x minus 5y. Both are same. Maximize 6x 5y, nothing but the minimization of the minus. That means if you're trying to maximize f of x, it is same as minimize minus f of x. Why, sir, we need to why we can't use only maximize, not why we are trying to convert into minimize? Because in Python and the MATLAB, the libraries are available that called the linprog library, linprog method, that is used to solve the minimization problem. That's why I'm trying to convert our maximization problem into the minimization problem, simply multiplying our objective function with the negative sign. Simply multiplying our objective function with the negative sign. Our objective function with the negative sign. So hope you understand. Okay. So now why I'm saying that? So now what happened? Minimize minus 6x minus 5y. And your constants are say as it is x plus y less than or equal to 5 and 3x plus 2y less than or equal to 12 and x comma y is greater than or equal to 0. X comma y is greater than or equal to 0. Hope you understand. Now mathematical modeling is available. Now how we solve it using the Python. So if you want to solve this after converting the mathematical modeling, if you want to convert it, solve using the Python, so this is the piece of code you can use. So actually in scipy.optimize, so you need to import linprog method. You need to import linprog method to work on the linear optimization problems. If you want to work on the linear optimization problem, you have to take it. After that, you have to give the objective function coefficients and you have to give the you have the constraints. You have the constraint, right? So you have to give the left-hand side of the inequality constraint values and right-hand side of the inequality constraint values. Okay. After that, you have to give the boundaries also. So what are the boundaries? X should be greater than 0, Y should be greater than 0. So minimum value is 0, maximum value is infinity. Minimum value is 0 and maximum value is infinity. So you have to give the boundaries also. After that, just call this function. So opt equal to, you have to call linprog method. You have to pass your objective function like a C. C means cost function, nothing but your objective function. And you have to pass LHS until left hand side of the equality sign and also right hand side of the equality sign. And also you have to pass your boundaries and you can use which method you want to use. I am using the simplex method to solve this linear optimization problem. So once you run this piece of code, then it will give the solution. So we will try to implement the same thing now. Fine. So what I told to solve this problem. So once again, we will go back to our problem here. We'll try to go for the, so because this is my assignment, this is your first assignment, I will explain this problem and you have to solve this assignment and you have to write a code and upload into the canvas. Write a code and upload into the canvas. Okay. Please listen carefully. Now, when we are converting this problem case study, this problem statement into mathematical modeling, and because your linprog method will work for the minimization problem, so that I'm trying to convert this maximization problem to minimization problem. So instead of maximize, minimize minus 6x minus 5y. Just multiply with the minus. Now, you can write the code from scipy dot optimize, scipy dot optimize, import scipy dot optimize, import linprog. We are trying to import linprog method. One minute. Just I'm trying to sign in. Sign into my Google Colab. I think I'm not introducing the Google Colab because I think most of you are aware of it. So this is the Google Colab. We can run our Python code in cloud. So from scipy dot optimize, you have to import linprog method. Import linprog method. Import linprog method. So that's the first thing. Okay. So we will see whether it is successfully executed or not. If it is successfully executed, then we will move to the next part. Done. Okay. Now, after importing the linprog method, next task is we have to prepare our objective function. The objective function means what are the coefficient of x? Minus 6. What are the coefficient of y? Minus 5. So we have to call your object function as a matrix. The values are minus 6 comma minus 5. The values are obj equal to minus 6 comma minus 5. Okay. So this we are calling, it's completed, right? Now coming to the constraints. We have to convert these constraints into the mathematical form. We are trying to convert these functions into the mathematical form. These constraints into the matrix form. So matrix form means how we can write x coefficient is 1, y coefficient is 1, here x coefficient is 3, here y coefficient is 2, and multiply with x and y. Then what happened? 1 into x, x plus 1 into y, y, x plus y. Similarly, 3 into x plus 2 into y. These should be less than or equal to 5 and 12. 5 and 12, right? So this is called as the left-hand side of the inequality constraint. And this is called as the right-hand side of the inequality constraint. So we have to pass these two values. Okay. So how we pass these two values? For the left hand side of the inequality constraints, that's equal to, so what is the left hand side? What is the row? 1 comma 1. So 1 comma 1 and comma. What the second row? 3 comma 2. 3 comma 2. And similarly, what is the right hand side of the inequality constraints? 5 and 12. So 5 comma 12. Okay. So that's also completed. So we are calling the left hand side and right hand side. That's also completed. So, okay, we have the object function readily available. We have the constraints readily available, and we have the boundaries. So how we get these boundaries, you can see. So you can use any variable. Boundaries equal to, so what is the lower limit and what is the upper limit? What is the lower limit? That means why these are two terms I am written again and again, because one is for the variable x, another is for the variable y. So we can give the boundaries. So you can give any name. Boundaries equal to, so boundaries equal to, so here you can write 0 comma, so the lower limit is 0 for the variable x. And for upper bound is x should be greater than or equal to 0. Either 0 or greater than 0 means anything up to positive infinity. So up to positive infinity, so that I will write the INF. Okay. Similarly, so you can call the, similarly, you can call the y values also. You can call y values also. So this is the y values also 0 and infinity. 0 and infinity. Okay, 0 and infinity. Hope you understand, right? So now the boundary is also completed. The boundary is also completed. Okay, the boundary is also completed. Now everything ready. So you have the object function, that is the OBJ. You have the constraints in the form of the matrix, that the LHS and RHS of the inequality constraints, and you have the boundaries that also available. Now you have to solve the problem using the linprog method. So for that one, you can write opt equal to the variable name. You can use any variable name. Call your method linprog. Call your method linprog, and you have to pass. So linprog, and you have to pass all the things. First, you have to pass the cost function. Cost function is nothing but your objective function. You have to pass, and also you have to pass the AUB. AUB is nothing but the, you can see anything. AUB, BUB, and A equivalent, B equivalent, BONDS, bounds, anything. All the things are available, right? So you have to pass everything. So AUB equal to, AUB nothing but the coefficient matrix of a inequality constraints. So for your inequality constraints, what are the coefficient? Is an inequality constraint, right? What are the coefficient matrix? 1, 1, 3, 2. Where it is available? 1, 1, 3, 2. That's the LHS IQ. So this is, can be written LHS underscore IEQ. Similarly, what next we have to pass? BUB. That means constant matrix of your inequality constant. So the constant matrix RHS IEQ. So RHS underscore IEQ. So I'm passing that also. Okay. So I hope you understand, right? So I'm passing the objective function. I am passing the inequality constraints, coefficient matrix, inequality constraints, constant matrix. And also you have to pass boundaries. Also you have to pass the boundaries. So what are the boundaries are available? That is the B and D. That is the B boundaries equal to B and D. And you can call your method. You can see method, which method you want to use, you can call. You can write a method. So which method you want to use? I want to use the simplex method. That's it. So this single line will be helpful to solve your optimization problem. Okay. So you can run this cell. That's it, completed. Now if you want to outputs, you want the solution. So you can write opt.x. Then it will give the solution. What is saying that 2 and 3. Actually, what are the variables? What are the variables in our problem? Our variables are x and y. That means you have to tell your client about the how many number of A-type chocolates, that is the x, and how many number of B-type chocolate, that is y. You need to produce, that you have to tell, right? That means you have to tell the value of x, you have to tell the value of y. So those are the values x and y. So what is the final solution for my case study? I have to suggesting my client, that is he produce two A-type chocolates and 3 B-type chocolates, then he will get the maximum profit. Two A-type chocolates and 3 B-type chocolates, then he will get the maximum profit. Okay. So this is how we are going to solve. This is how we are going to solve. But this complete GitHub link already shared in the canvas. Just by seeing that thing, you are going to work on this assignment 1. So this is the assignment 1. You have to carefully read this case study and convert it to the mathematical modeling and solve using the and you have to solve using the Python and upload your what's called your GitHub file, your Google Colab link into the Canva, into the GitHub, and upload that GitHub link into the Canvas. So if you have any difficulty and if you don't have a GitHub account, then simply After writing your code on a Google Colab, simply click on share button. Simply click on share button. So that you can, before that one, you can click on this line. Okay, simply try to click on this one and share this link in a canvas. But I am recommending, if you have a GitHub account, so go to file and click on, you can see here, you can find a save a copy in GitHub. So just save a copy on GitHub and your complete notebook will be uploaded into the GitHub, and that GitHub link you have to share in the canvas. That GitHub link will be like this. This is my GitHub link. So that I shared with you, right? Similarly, your GitHub link also upload into the canvas. So this assignment will be evaluated for the 10 marks. Okay. So this is how we are going to work with the linear optimization problem using the Python. Okay. So now I want to stop here. If time permits, today, if time permits, I will explain how to solve the linear optimization problem in the MATLAB also. In the MATLAB also, we have the linprog method or linprog function. So we can use that linprog function to solve this linear optimization problem in the MATLAB also. That we will discuss today only if time permits. I don't want to move these concepts for the tomorrow. Tomorrow, I'm trying to complete focus on the ANN architectures and the different learning rules. Okay. Now, hope you understand as of now. Now I will move to the next concept. So till now we discussed about the what mean by the optimization, what the mathematical modeling, what are the different types of what are the different parts in a mathematical modeling of an optimization problem, and also we discussed about the different types of the optimization problem that is called linear and non-linear optimization problems. Okay. Now, hope as of now you clear up to here. Now I'm trying to focus on only non-linear optimization problem, because in our deep learning or in the machine learning, we require the concept of the non-linear optimization problem. For to understand only, I'm explaining the linear optimization problem. But in case of the deep learning or machine learning model training or deep learning model training, ANN training, we are using the non-linear optimization, not linear optimization. But to understand you, I have explained the linear optimization and also non-linear optimization. Okay, now we are much focused on the nonlinear optimization problem, and we are going to discuss about the gradient descent algorithm. We are going to discuss about the gradient descent algorithm. Okay, so please carefully concentrate for the next 30 to 45 minutes. So where I am trying to explain the nonlinear optimization problem solution using the gradient descent algorithm. So that is a very important, especially in machine learning or in the deep learning. Okay, so hope you understand, right? Now we are much focusing on solving non-linear optimization, problem, non-linear optimization problem using gradient descent algorithm. So we are going to discuss. Okay, and this gradient descent algorithm is very, very important for the AI perspective, either it is a machine learning or it is a deep learning. So it is very, very important. Gradient descent algorithm. Fine. Right. Now, as I said earlier, so what, especially in the nonlinear optimization also, in machine learning and deep learning, we need unconstrained nonlinear optimization problem only. Unconstrained, that means we no need to bother about the constrained nonlinear optimization problem. Just we will focus on the unconstrained nonlinear optimization problem because it's very important. So just take an example. So just take an example. So that is called, let us assume I want to minimize f of x equal to, I want to minimize f of x equal to x square plus 5. I want to minimize f of x equal to x square plus 5. Okay, so there is no constraints. There is no constraints. So because this is an example for the unconstrained non-linear optimization problem. Unconstrained non-linear optimization problem. Okay, unconstrained non-linear optimization problem. Hope you understand, right? Unconstrained non-linear optimization problem. Right? Now, how we solve this unconstrained, because there is no constraints, and it is a non-linear because I have the square term x square plus 5. That's why it's called as the unconstrained non-linear optimization problem. And moreover, in machine learning or in the deep learning, we require this unconstrained non-linear optimization only. That's why I'm trying to explain this solution for an unconstrained non-linear optimization problem using the gradient descent algorithm. Later, I will apply the same gradient descent algorithm to our machine learning or neural network part also. That's why the first day is very, very important. If you are new to artificial neural networks, you are familiar with the neural networks, means then that's not required. But even though, based on my observation, most of the students are directly implementing the neural networks used by various libraries are available in the Python, by seeing the various blogs, by using the chart GPT and everything. But if you ask some questions, back-end questions of your neural network models, no one is able to give the answer because they don't know what will be the mathematics behind the neural networks. That's why, of course, if you want to implement neural networks, no need to join for this FDP because many blogs are available. But what the specialty of this FDP is, we are trying to explain everything from basic mathematics by using the basic mathematics behind every neural network model. Okay. So now, how we will solve this one using the gradient descent algorithm? Okay. So actually, how this gradient descent algorithm will work, we will discuss first. Now I want to draw the plot of my objective function. I want to draw the plot of my objective function. So this is the plot I want to draw for my objective function. So what is my objective function? F of x. And my objective function value is varying on which variable x, that is called as destiny variable. So this is my x and this is my f of x. Okay, so x will be varying from the plus infinity to minus infinity. Max value will be anywhere, any value from the plus infinity to minus infinity. And what I am trying to do, I am trying to find trying to minimize my function f of x. So minimize function f of x is nothing but identify the value of x from minus infinity to plus infinity, where my function f of x will be minimum. Hope you understand. So minimize f of x is nothing but identify the x value from the minus infinity to the plus infinity, where my f of x value will be minimum. That point we have to identify. They're called minimize f of x, nothing but minimize f of x is nothing but identify the x value at which my function f of x will be minimum. Right? Similarly, in the previous problem also, maximize profit 6x plus 5y, nothing but identify the x and y values. Finally, I'm getting x equal to y equal to 3. Identify the x and y values at which my profit will be maximum. At which my profit will be maximum. Understood? So here also, I'm trying to identify the value of x. X value will be varying from the minus into plus into anything because I'm not giving anything. I'm not giving the boundaries also. I'm not giving any constraints also. I'm asking you minimize f of x. X value will be anything, minus infinity to plus infinity. I'm trying to do this one. Suppose if x equal to 0. Suppose if x equal to 0. Okay. If x equal to 0, what is the f of x value? That is the 5. That's the 5, right? If x equal to 1, if x equal to 1, if x equal to 2, if x equal to 3. So if x equal to 1, what is the f of x value? 6, right? Agree. It is 6. And if x equal to 2, 2 square 4 plus 5, 9. So somewhere here you have the 9. And 3 means 3 square, 9 plus 5, 14 means somewhere here. So my function will be varies like this. Okay. Suppose if x equal to minus 1, if x equal to minus 2, if x equal to minus 3, like that, what happened? When x equal to minus 1, again, minus 1 whole square, 1 plus 5, 6. So again, it will be here only. When x equal to minus 2 whole square, 4 plus 5, 9. So again, somewhere here only. And minus 3 square, 9 plus 5, 14 is somewhere here only. Okay. So now, so this is my curve. This is how my object function varies with respect to, this is how my object function varies with respect to x. Okay. Now I am trying to identify the value of x at which my function will be minimum. So by seeing this curve, by seeing that function, we can easily say that when x equal to 0, my function will be minimum and the minimum value of the function equal to 5. That we know because it's a very, very simple problem. But why I took this simple problem is to make the participants to understand easily about the gradient descent algorithm. I can take a very complex problem. I can explain, but it's very difficult to understand. That's why I took very small problem to explain the gradient descent algorithm, right? Now, as per the gradient descent algorithm, what you will do? How gradient descent algorithm will work to find, to minimize, or to optimize an optimization problem. No, sorry, objective function. To optimize an optimization problem, objective function. That means how gradient descent algorithm will help for your objective function f of x to identify the best x value at which my function f of x is minimum. How GDA, gradient descent algorithm, will work. That we will discuss. Algorithm we will discuss. Okay, carefully understand or observe here. So in gradient descent algorithm, first step is you need to randomly choose, randomly choose decision variable value. Decision variable value. Randomly choose decision variable value. We have to randomly choose decision variable value. So what is the decision variable here? X is our decision variable. So you have to choose the random value of x anywhere from the minus infinity to plus infinity. Any value. You can choose any value of x from the minus infinity to the plus infinity. You can choose any value from the minus infinity to plus infinity. Okay. So let's assume as per the first step, I am assuming x equal to 3. Randomly, I'm choosing x equal to 3. Randomly, I'm choosing x equal to 3. Randomly, I'm choosing x equal to 3. Okay. So that's the first step. So whether it is a deep learning or whether it is a machine learning or it is a small optimization problem, you need to randomly initialize your decision variable in case of the optimization problem. If you go into the machine learning and deep learning, you can call it the model parameters. Okay. The term I'm saying here, I'm saying a decision variable, whereas in case of the machine learning models, so we can call it as a what's called model parameters. We can call it as a model parameters. We can call it as a model parameters. 1 minute, please. You can call it as a model parameters. Okay. Okay. Forget about that model parameter statement. Tomorrow we are able to understand. So as of now, okay, I'm trying to identify the x value at which my function f of x is a minimum, and I'm trying to find that x value. So for that one, I want to use the gradient descent algorithm. Again, I'm saying that for this problem, or understanding the gradient descent algorithm, writing a code for a gradient descent algorithm, it is not required. By seeing that problem, we can easily tell at x equal to 0, function will be minimum, and minimum value of the function equal to 5. But to understand, so I'm taking a small example. Okay, fine. So I took the x equal to 3. So now, what is the next step? Next step is, you can see here, for example, you have a function, you have a line equation y equal to mx plus c. We know simple line equation. In this line equation, what is the m? M is called as the slope, right? So this is called as the slope of a line, right? Now, if you want the slope, then what you will do for your function dy, you have to differentiate with your decision variable, then you will get the m value, right? You can get the m value at that x. So if you want to find the slope of any function at a particular x value, then what you can do, you have to first order derivative. You have to derive your function y or f of x with respect to x. It will give the slope, right? So in the gradient descent algorithm also, your step 2 is calculate slope of function at x value, what the x value you are choosing at a given x value, using how you calculate the slope now, just using the gradient. This is called as the gradient or first order derivative. So at x equal to 3, we are initially the x equal to 3, right? So x equal to 3, this is the point. This is x equal to 3, this is the point. At this point, drop a tangent, and try to calculate the slope at this point. If you want to calculate the slope at this point, how we can calculate the slope at this point? Simply calculate the dou f by dou x at x equal to 3. So what I mean to say is, so once you randomly initialize the x value, try to calculate the slope at that point, at that initial x value based on the first order derivative or nothing but the gradient. That's what's called the gradient descent algorithm. Right? So your first step is you have to calculate your derivative or gradient of that function at current x value or the current x value 3 that you have to do. Okay, so that's equal to what the dou f by dou x value now? Dou f by dou x, that's called 2x at x equal to 3. So finally, this is the 2 into 3, that's equal to 6. That's the gradient value I calculated. Okay, so calculate the gradient. Now tell me, so in this type of objective function, our goal is trying to reach this bottom point. Our goal is to reach this bottom point. So if you draw the tangent at this bottom point, so what will be the slope of this tangent line? What will be the slope of this tangent line? Or you can some other way you can call it's the y-axis and the x-axis. And I'm writing the y equal to 3. So y equal to 3 means it's a line parallel to the x-axis. So what is the slope? Slope is nothing but the dou y by dou x, because 3 is a constant that's equal to 0. So at the optimal point, when you draw the tangent, which is parallel to your x destiny variable, so at this point, your gradient f dash of x or dou f by dou x equal to 0. Dou f by dou x equal to 0. Okay. So our goal is we randomly choose the x value somewhere in the set space. And if we are calculating the gradient at that point, our ultimate goal is we are trying to reach our point. We are trying to update our x value in such a way that the gradient or slope equal to 0. When the gradient or slope equal to 0, then that point will be the minimum point, right? At the minimum point, if you draw the tangent, that will be parallel to the x-axis. That means the slope equal to 0. That means gradient equal to 0. Initially, I choose x equal to 3. I got some slope 6, gradient 6. My goal is I want to find the value of x at which my gradient equal to 0. At which my gradient equal to 0. Okay. Now see, when x equal to 3, I am getting the slope positive slope. I am getting the positive slope. So when I'm in the positive slope, but my goal is I want to reach at the 0 slope point. For example, if your initial x value equal to -3, let's assume. If the initial x value equal to -3, then what happened to the gradient? If initial x value equal to -3 somewhere here, so what will be the gradient? The gradient f dash of -3 equal to how much? It's the -6. Agree? That means, so in this side, your gradient or slope equal to negative. And in this side, the gradient or slope equal to positive. Whereas at the optimal point, the gradient or slope equal to 0. The gradient or slope equal to 0. So my goal is, let's assume initially my x value equal to 3, I'm getting the positive slope. Now I'm trying to move this point. I'm trying to update this point from the positive slope to negative slope. If my slope is positive, I'm trying to move this point toward the negative slope side. When I'm trying to move this point toward the negative slope side, then it will be reaches this 0 slope. That's what I want, right? That's what I want. So whenever you have the positive slope, trying to update your point toward the negative slope side, then you will reach your 0 slope point. If your slope is negative, if your slope is negative, then try to move this point toward the positive slope side. Then it will reach at this 0 slope. That means randomly initialize your x value. update the point. If it is a positive slope, update the point toward the negative slope. If it is a negative slope, update the point toward the positive slope. If you're updating like that, definitely you will reach this zero slope point. Definitely you will reach this zero slope point. That's what we want. So we want the value of x at which your function will be minimum. Your function will be minimum means their gradient equal to 0. So I want to find that zero slope, zero gradient point. So I don't know where the zero gradient will exist. That's why just simply I am initializing some x value, some value to my descent variable. Now, if my gradient is positive, I'm trying to update toward the negative gradient. If my gradient is negative, I'm trying to update toward the positive gradient. Then it will reach as my zero slope or zero gradient point, that is called as my optimization point or minimization point. Understand, right? Now what with gradient is calculated. This is the actual heart of a GDA, gradient descent algorithm. Heart of the work, gradient descent algorithm. Hope you understand, right? So next step is step number 3. Next one is a step number 3. So we initialize x value, we calculate the gradient value. So what we are going to do, we are trying to update the point. So update the point means we have to calculate the step length, delta x. So calculate the delta x, nothing but the step length. Step length calculation. Step length calculation. So step length calculation means, so delta x calculation. Now we can calculate the delta x. I said that if your gradient is positive, move toward the negative. If the gradient is negative, move toward the positive. How we calculate the gradient? Dou f by dou x at x equal to 3, current point, the gradient. If the gradient is positive, move the point toward the negative side. The gradient is negative, move the point toward the positive slope side. So you can see that opposite. If positive slope, move toward the negative. If negative slope, move toward the positive. So how we will convey that part? Simply keep negative sign. If it is a positive slope, it will become negative side movement. If it is a negative slope, it will become positive slide movement. That's why we have to get the minus dou f by dou x. So this will tell you if it is a positive slope, move toward the negative slope. If it is a negative slope, move toward the positive slope. This sign will give. Now, how much step length I can take, how much distance I can update this point from here to here. This one will be decided by a parameter called learning rate, that is called the eta. So learning rate, that is the eta, will decide how much step length we can include. How much step length we can include. So how much step length we can include. Okay, how much step length we can include. That depending upon the learning rate eta. Generally, the value of eta is lying between 0 and 1. 0 and 1. Okay. Okay, we will discuss about the learning rate impact on the updation of the destiny variable. We will discuss later. So some value you can choose initially. So you can choose some value eta as 0.1 or something. Okay. So that eta value you have to include here. So the step length, that means how much distance from here to here. It is a negative side or positive side, that depending upon the minus. And but how much length it will take, when it is updating, how much jump it will take from the one point to the another point. That is decided by learning rate eta. That's why I multiply the eta. So this is called as the step length. So step length is minus eta dou f by dou x. Minus eta is called the learning rate. Dou f by dou x is called the gradient. Minus we are taking because if you are in the positive slope side, move toward the negative slope side. If you are in the negative slope side, move toward the positive slope side. Hope you understand. Okay. So once you calculate the step length value, next step is step 4. That is called as the step 4. Step 4 is update. So update x value. Your decimal variable value you are going to update. How we are going to update x value? How? X equal to x plus delta x. X value, the initial x value 3 plus delta x value coming from here. Let us do, we are considering the eta equal to 0.1. So that's equal to minus 0.1 into dou by dou x at x equal to 3. That is called 6. So that's equal to minus 0.6. Now what is the x value? New x value, that is the x equal to x plus. X value is 3 and the delta x value is minus 0.6. That's equal to 2.4. That's equal to 2.4. Okay, see, we know, right? Initially, we are choosing a point 3. But our goal is to reach this point. See what happened, x value is from 3 to, it will jump to the up to 2.4. Sometime later, it will come something like, finally it reaches to 0. This is in the first iteration only. Okay. So what next? So x is updated. Now what next? So we are going to repeat the step number 2, step number 3, and step number 4 every time. Again, use this 2.4 and calculate the gradient again, and calculate the step length again, and also update the x value. Then the 2 iterations are completed. And again, with the new x value, again calculate the gradient, again calculate the step length, again update the x value. 3 iterations are completed. This process will be repeated. This process will be repeated until your slope equal to 0, or that is the convergence criteria. Convergence criteria means maybe the slope equal to 0, but it's not a good in deep learning case. We can't get exact slope 0 point. Something near your slope 0 point you will receive. That's why slope equal to 0 convergence criteria is not suitable for the deep learning or machine learning. So what we will choose? Generally, we will choose the number of iterations. Maybe we will take the number of iterations equal to 10 or 100 or 200. So those number of iterations, your x values will be updated. For example, at a 70th iteration, you are reaching this point. From 70 to 100, you will be here only because you are already slope equal to 0. When the slope equal to 0, what is the delta x value? When the dou x value equal to 0, delta x value equal to 0 only. When the delta x value equal to 0, x equal to x. So your point will not update. So from the 70 point to 100 iterations, your point will not update. That will be stayed there only. Hope you understand what I mean to say. Okay. So I'm trying to draw the small flow chart for this gradient descent algorithm. So you need to start, and here you need to read x value and number of iterations. How many number of iter max? How many number of iterations you want to run? Let us assume 100. As example, I'm saying 100. And also you have to read x value. That means randomly read x value. Something like earlier we choose x equal to 3, or you can choose 5. You can take -3. You can take -10. You can take -100. Randomly you can choose. That's the first part. Iter max, that is equal to 100. And eta, you can choose some learning rate. Eta equal to 0.1. Eta equal to 0. Okay. So tell me what will be the next step for us. Next step is calculate gradient. So calculate gradient dou f by dou x at x value. Whatever the x value you are initialized, let it be x0. At x equal to initial x0 value, you have to calculate the gradient. At current x value, that means current x value, at the current x value, you need to calculate the gradient. Okay. So after calculating the gradient, what you have to do? Calculate the step length. So delta x equal to minus eta into dou f by dou x. That's what we calculated here, na gradient that you have to incorporate here. After calculating the delta x value, what you are going to do? X equal to x plus delta x. You are going to update your x value. You are going to update your x value. So after that, so you can check the decision making. Decision making means here you have to check your current. So let us assume initially. Sorry, I forget. Yeah, iter max equal to 100. That's nothing but the max number of iterations, and eta equal to 0.1. And in addition to that, you can choose starting iteration iter equal to 1. It is the first iteration. So we are in the first iteration. We are calculating the gradient. We calculate the step length. We updated the x value. Now you can increment your iteration. So iter value is equal to iter plus 1. We are going to increment. So after that, what we are going to do? So you have to check it. So whether your iteration value, current iteration value greater than iter max or not. That means we are changing the algorithm. You have to run the algorithm for the 100 epochs. You are running the algorithm for the 200 epochs. Whether you are reaching the 100 epochs. If it is S, vector max is equal to 100. If it is iter value also equal to 100, crossing the 100 value, then what you have to do? Simply stop your algorithm, and whatever the X value you are getting, that is your final X value. If it is no, that means your current iteration value not 100, it is less than 100. It is S. That means current iteration reaches the 100 iterations. If not, if no, then where to go? Again, go back to your gradient calculation and calculate the gradient value, calculate the step length value, and update the X value. And these steps will be repeated again until you are reaching the max number of iterations. So this is the simple flowchart for the gradient descent algorithm. The simple flowchart for the gradient descent algorithm. Okay, hope you understand, right? Okay. So if you understand this complete part, so next post break, now it is around 2 minutes to go for 3 o'clock. So we'll take a break of 15 minutes. So now we will take a